Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Tifr, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 33 of the mathematical physics, in which I'm going to discuss bisection method and Newton-Raphson method today. And this is the numerical analysis which I have started. Okay. And also I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay. So let's get started. Okay. So meanwhile, let me just check whether I'm audible or not. Then I'll proceed further. Okay. And also, I would, yes, I'm audible, so I'm proceeding further. Okay. So that polynomial of equation. Okay. That is bisection. So polynomial of equation. Polynomial of equation. Okay. Polynomial of equation. So if, okay, so we have been given that any polynomial, that is fx equal to uh, ax square plus bx plus c. So this is the polynomial which is given. Okay. So if fx is continuous, okay, if fx is continuous, that is polynomial. Okay, continuous. Fx is continuous in uv, where uv are real number. Okay, are real number. uv are real number. Okay, real numbers. So then, okay, so if this is polynomial and if fx is continuous in uv are real number, okay, in between this, okay, uv are real number, then that implies fu and fv, okay, f is continuous and if f is continuous in between this interval, okay, u and v, uv are real numbers, okay, real numbers. In that case, fu and fv will find out and they will be of opposite sign, okay, are of opposite sign, are of opposite sign. Okay, so for example, like this. Okay, this is 2.1 and this is 2, like 1.5. Okay, this number is between 0.5 is 1.5 is between 1 and 2. Okay, and some points are there, like if fx is 0, if fx value is 0, right, a function, this is 0 fx. Okay, means odd number of real roots in the interval. Okay, and fx is 0, then odd number of real roots. Real, I'll solve question, then it will clear your doubt. Okay, so all number of real roots in the interval, in interval u and v, odd number of real roots in the interval is, okay, if fx is 0 and they are of opposite sign. Okay, and second is this one, fu, and if fu and fv are of the same sign, same sign, then fx equal to 0 implies even number of roots. Okay, roots in interval u. Okay, so this is what you need to know. Now I will solve one question. Okay, and then we'll go for bisection method. Okay, so I'll solve question, then this will clear it. Then this will make you this will clear your doubt. Okay, the question is, if there is if there is a real root of if there is a real root of x square minus 3x plus k. Okay, so if there is a real root of this polynomial in the interval minus 1 comma 1. Okay, then range of k range of k you need to find out. Okay, so if there is real root of x square minus 3x plus k in the interval, so there is a real root exists between this interval. Okay, for this polynomial, then we need to find out range of k. I'll solve question, then it is going to clear your doubt. Okay, so now, okay, so one root in this. Okay, so it means what we are going to do, since one root is in interval minus 1 and 1, this means f minus 1 and f1 should be of opposite sign. Okay, I have explained, if root exists there, then the f1 and f minus 1 and f1 should be opposite. The sign should be opposite. Okay, opposite sign. Okay, f1, this should be opposite sign. Okay, so now we'll find f minus 1. Fx is given. Okay, I'll write this. Fx is given. Fx is given, that is x cube minus 3x plus k. Okay, so now we'll find f minus 1. F minus 1 is going to be 1 square minus 1 square minus 3 into minus 1 plus k. Okay, so this value is going to be 1 plus 3 plus k. So f minus 1 value is going to be k plus 4. Okay, now we'll find this one, f plus k. Okay, f plus k, f plus 1. Okay, f at 1. Okay, f1. So this is going to be 1 square minus 3 into 1 plus k. Okay, so this value is going to be 1 minus 3. We have taken this one. Okay, f equal to 1. Okay, x equal to 1 we have put. Okay, so this is going to be plus k, and this value is going to be k minus 3. My apologies, k minus 2. Okay, we have to find the range. Okay, range of k. So because we know that if a root exists between this interval, then f1, f minus 1 and f1 will must be opposite sign. Okay, this sign must be different. Okay, so now we'll take two conditions. Okay, two cases. The first is, if f minus 1 greater equal to 0, implies that greater equal to 0 means that should be positive, right? And if f1 f1 should be less equal to 0, that implies this value is minus sign. Okay, so this means the first one, f1 value we have got, that is k minus that is k plus 4. F minus 1 we have got, right? K plus 4. So k plus 4 should be greater or equal to 0, right? This is f minus value, right? K plus 4 greater or equal to 0, that implies k should be greater or equal to minus 4, right? And similarly f1 is this, k minus 1 should be less equal to 0, that implies k value should be less equal to 1, okay, less equal to 1. So it means, this implies k less than 1, right? So this implies this k is between minus 4 to 1, right? K is between minus 4 to 1. Is between minus 4 to 1. Now we'll take second case. If f minus 1 less equal to 0, that implies minus sign, that is negative, and f1 greater equal to 0, that implies plus b, positive, right? So the f minus 1 value is k plus 4 less equal to 0. It means k is less equal to minus 4, and similarly f1 greater equal to 0 means k minus 2 greater equal to 0. That means k is uh, less equal to 2. So here you can see k is less than, here you can see k is less than minus 4. Okay, minus 4 is greater than k, right? And here you can see k is greater than k is uh, this is k is greater than 2. It's not possible, guys. First k is going to be less than minus 4. At the same time, k is greater than 2, right? It's not possible, right? So it means the range is going to be 2x minus, so the range of k is going to be like this. K is between 2 to minus 4, right? Which is not possible. Which is not possible because k is less than 4. At the same time, k is greater than 2. Not possible, right? But this is the accurate answer, because k is less, there it's correct, because k is greater than minus 4 and k is less than 1. So this is the correct, right? So the range of k is between minus 4 to 1. Okay, oh, sorry, minus 4 to 2, guys. Here we have made mistake. It's k2, no? It's 2. K minus 2, so it's 2. K is between minus 4 to 2. I hope, guys, it is clear. Next is bisection method. It's important method, guys, because we have got question in CSIR net 2023, okay, from bisection method. So I will solve that question as well, okay. Okay, so now bisection method. Bisection method, okay. Bisection method is like, if fx is any function, okay, fx is a function, okay, polynomial, okay, and fa, and so this is a polynomial, and there is a root of this polynomial between a and b, okay, between this limit a and b there is a polynomial. So it means uh, it means fa and fb, if there exists any root that of this polynomial between a and b, then fa and fb, f and fb sign must be, they must be opposite in sign, okay, opposite sign, they must have opposite sign. So okay, so they must have opposite sign, okay. and okay, and we can write, if this is the case, then C is going to be A plus B by 2. The root is going to be A plus B by 2. Okay, so this is about the bisection method. Now I will solve a question, then that bisection method is going to be clear to you. Okay, well, so I'm going to start. I'm going to solve the question. Okay, and here we can write A and B, right? So C equal to this, right? So this means FA and FC, FA and FC should be opposite sign. Or second condition, if this is not, then FC and FB, because this is the root we have taken, right? Now FA will find FA and FC. If they are opposite sign, then root will exist between them. If FC and if it is of same sign, then we'll check FC and FB, and if they are an opposite sign, okay, then root will exist between them. Okay, opposite sign. Okay, so then root will exist between these two, means between C and B. Okay, if they are if FA and FC are opposite sign, then root will exist between A and C. Okay, so I'll solve one question, then your all doubts are going to be clear, and you will be able to solve questions by bisection method easily. Okay, so I'm going to start this question. Okay, this is the question which is asked, right? Okay, so question is, just give me 1 second. Okay, this is the example, and then okay, so question is, x cube minus 4x minus 9 equal to 0. Okay, this is the question, and by bisection method we have to find the root. Okay, after two iteration. Okay, so now this is the one, and an interval is given. Okay, interval is given. So now this is the question, and after two iteration we have to find out the root. Okay, so what we are going to do, we'll find f0. Okay, we'll put value x equal to 0. So this, if we put that, this is going to be 4 into 0 minus 1. This value is going to be negative. Okay, okay, now we'll find f1. Okay, if you find f1, so you can see again it is going to give negative value. Okay, like 1 cube minus 4 into 1 minus 9. So this is also going to be negative value. Now we'll put f equal to 2. If you do f equal to 2, then it is going to be 2 square minus 4 into 2 minus 9. Okay, so again it will give negative value. We need one negative and one positive value. Okay, now we'll find f2. Okay, f3. F3 is going to be 3 cube minus 4 into 3. We'll put value here, right? Minus 9. And this is going to be plus sign, because this is 27 minus 12 minus 9. And this value is going to be 6, that is positive, right? This is positive, this is negative. Means F2 and F3 will see the nearest value, right? So F2 and F3 are positives and opposite sign, right? This is negative, this is positive. Means root exists between 2 and 3. Okay, because these two, because F3, F2 and F3 are of opposite sign. I have explained, right? So this means since F2 equal to negative, right, sign, and F3 is positive sign, means a different sign, right? This implies root is between. This implies root is in interval 2 and 3. Okay, so root is in interval 2 and 3. Okay, now we'll find C root. Okay, so that is going to be a plus b by 2. After two iteration we need to find. Okay, so a plus b by 2, and so this is going to be a is 2, b is 3 by 2, so this is going to be 2.5. Okay, so it means we'll check, there are two conditions. Okay, there are two conditions, that is root will be either between this one 2 and 2.5, 2 and 2.5, or root will be between 2.5 and 3. Okay, now we'll find, for that we will find f2 and f2.5. if they are opposite sign, they are of opposite sign, then root will exist between this. Again, here we'll, if it is not, then we'll find f2.5 and f3. If they are of opposite sign, then root will exist between 2.5 to 3. Okay, so it is going to be f2 will find the value. So f2 value is going to be, that is 2 square minus 4 into 2 minus 9. So this is going to be minus 9, that is negative value. And here we will find 2.5 square. This is cube, guys, not square. Okay, cube. Cube minus 4 into 2.5 minus 9. Okay, so this value is going to be 15.625 minus 9 minus 9, and this is going to be negative value. So both are negative value. Okay, both are of same sign, implies root doesn't exist between this interval. Okay, root doesn't exist between this interval. Now we'll check this one, this one. Okay, so we'll check f 2.5. This is negative value we have already got. Okay, now we'll find f3. F3 is going to be 3 cube minus 4 into 3 minus 9. Okay, so this is going to be 27 minus 12 minus 9. So this is going to give plus value. Okay, plus 6 or plus value, right? This is going to be give plus value. So one is negative value, and f 2.5 is negative, f3 is positive. They are of opposite sign. It means root exists between, root is between these 2 points, right? So now we'll find out this one, D. Okay, D. So for D, what we are going to do, D is C plus, D is going to be this one, 2.5 plus 3 by 2. So this value is going to be 2.75. Okay, so now root will exist between 2.75 or this one. Root will exist between 2.5 2.5 and 2.75, or it will exist between 2.75 and 3. Okay, now again we'll check f2.5 and this value. Okay, similar thing we are going to do. Okay, if we check this for this 2.5 and 73, okay, so this is existing between this, right? 2.5, 2.75 and 2. So again, if you check this f2.75 and f3, these are going to be positive sign. Both are positive sign. But here, this is negative sign and this is positive sign. So root will exist between this. Okay, this between 2.5 and 2.75. Okay, in this way we get, and then we'll find this e. We'll add this and then divide by 2, right? So then this will be the root. Okay, well, so this is the one. Okay, in this way we find this. This is the bisection method, guys. Okay, this we have done by first iteration and this is second iteration. Okay, so this is the value actually. Again, if it is said, if it is asked for 3 iteration, this is the answer, guys. Okay, so then again we'll check between this and this. Okay, and here we can check this is these are opposite signs, so root will exist between these two intervals, this interval, not this interval, because these value are giving positive sign. Okay, well, okay, guys. Now there's a question which is asked in CSIR net, which I'm going to solve. Okay, so 2 iteration means this is the answer. Okay, question is, now there's a question which is asked in CSIR net. CSIR net June 2023. Okay, so it is asking June 2023. Okay, and question is fx equal to x cube minus x square minus 1. You need to find out root in 3 iteration. Okay, 3 iteration. In 3 iteration. Okay, in 3 iteration. Okay, this is the function given. Same thing. So first we will find interval. Okay, we will find f1. F1 is going to give 1 cube minus 1 square minus 1. So this is going to give minus 1. That is negative value. Okay, now we'll find f2. F2 is going to be 2 cube minus 2 square minus 1, right? So this is going to be 8 minus 4 minus 1, so 3. That is positive value. So this is negative, this is positive, means this means root exists, then root exists between this interval 1 and 2. Okay, so now we'll find c. C is going to be 1 plus 2 upon, this is the question, guys, I asked in 2013. Okay, June. So bisection method is important, guys. Okay, so understand this. Okay, so this is 1 upon 1 plus 2 by 2. This is going to be 1.5. This is the first iteration. We have to do it in 3. After 3 iteration, we have to find the root. Okay, so so this is C. Okay, now we'll find 2 interval we have got, right? 2 interval, that is 1 and 1.5. Another is 1.5 into 2, right? 1.5 and 2. Now We'll check in two conditions, right? We'll check here again F1 and F1.5. We'll check it, okay? And also here we'll check F1.5 and F2. If this pair is going will give opposite sign, then we'll consider this. If this gives opposite sign, then we'll consider this. Okay, so we'll find F1. So F1. So this is going to be F1 is guys. Just wait. Yeah, this one. So we'll find F1. Okay, F1. So F1 is, we know, that is 1 2 minus 1 minus 1. So this is negative, right? And now we'll find F this one. F 1.5, so this is going to be 3.1 1.52 1.52 minus 1.5 square minus 1, and this value is going to be 3.375 minus 2.25 minus 1. Okay, so this is going to give 0.125, means positive value. Okay, so F1 is giving minus negative value and F1.5 is giving positive value. No need to check this. Okay, so it means root exists between 1 and 1.5. Root exists between 1 and 1.5. Okay, now okay, if you check this value, this is going to give positive sign, guys. Okay, this will give positive sign because 1.5 is positive, F 1.5 is positive. It means if we put x equal to 2, it is obviously positive. So these are positive signs, so we'll not take. Okay, so for here again we'll find that D. Okay, bisection D. So D is going to be 1 point. After 3 iteration we have to find. Okay, so D is going to be 1 plus 1 plus 1.5 upon 2. So this is going to be 1 point. This is going to be 1.25. 1.25. Okay. Now there will be two intervals. Either root will be between 1 and 1.5, or this will be in 1.5 and 2, right, in this interval. So again we'll find F1 and F1.25. Similarly here we'll find F1.5 and F2. Okay, so if you put this one F1, right, this will be negative value. F1.25 is also going to give negative value, right? No, right. So this is negative value we know, and this value will put, okay, 1.25. So this is going to give positive value. Okay, so this we are not going to consider. Okay, 1.25. Have you made any mistake? Yes, we have made mistake. Yeah. So this will be between this. Okay, 1.25. This will be between 1 and 1.25. Okay, 1 and 1.25, and this is 1.5, and this is not 2, this is 1.5. Okay, 1.5. Okay, 1.5. So this value is 1.25 is negative, and this value is positive, guys. This value is positive and this value is positive, because 1.25 is positive, means obviously at 1.25 is going to be positive. Okay, and obviously f 1.5 will also be positive, right? So so now exist root will exist between this limit, guys. This is second iteration is already done. Okay, second, and this is the first iteration C. This is the second iteration D. Now third iteration. Okay, So it means E is going to be this one, 1 plus 1.25 upon 2. So this value is going to be 1.25. No, no, guys, there is a mistake. We have made a mistake. We'll put the value here. This is also giving negative value, okay? This is negative value. If you put this value, this is negative value. And here, this is going to be negative value, right? And this is going to be positive value, okay? So it means root exists between 1.25 and 1.5, right? So E, the third iteration, is going to be 1.25 plus 1.5 by 2. This is bisection method, and if you solve it, this is going to be 1.375. This is the answer. This is after third iteration. Okay, this is the third iteration. We've got the value 1.375. Okay, so this is the root. Okay, and this is the root after third iteration. This is the root after second iteration. This is the root after first iteration. Okay, so they can ask first, second, third iteration. Okay, depending on the which part the question is asked. Okay, part B or part C. Well, guys, this is about this one, bisection method. Now I'm going to start Newton-Raphson method. Okay, Newton-Raphson method. Okay, Newton-Raphson method. Newton-Raphson method. Okay, so we know the formula. Formula is x1 equal to x0 minus fx0 upon f dash 0. Okay, so this is the one, or the general formula is xn plus 1. This value is going to be xn plus 1. This value is going to be xn minus fxn upon f dash xn. Okay, this is the formula, very important formula, guys. Okay, this is for first, and this is a general formula. Okay, this is the Newton-Raphson method. Okay, so I'll solve the question, then it will clear your doubt. Okay, so question is, polynomial is given x cube minus 5x plus 3 equal to 0. Okay, and initial guess is given. Initial guess is given x naught equal to 1. Okay, this is given. Okay, so we need to find value of x after 2 iteration. Okay, so this is going to be simple. So we will find first x1. X1 means this formula, right? X naught minus f x naught upon f dash x naught. Okay, f x naught upon f dash x naught. So first we will find here, this is, we have been given fx. Fx is x square minus 5x plus 3. Okay, so this is the fx. Okay, now we'll find f dash x. F dash x is going to be 2x minus 5. Okay, this is x cube, guys. Okay, x cube, it means this is x cube. So this is 3x square. 3x square minus 5f dash x. This is constant. This its differentiation is 0, right? So now we'll find x1. X1 is going to be x0 value is 1, and fx naught will put x naught equal to 1 in this fx, right? That is going to be fx naught. So this is 1 cube minus 5 into 1 plus 3 upon fx naught, right? F dash x naught. So we'll put x1 x0 equal to 1. So this is going to be 3 into 1 square minus 5. Okay. So x1 is going to be 1 minus, this value is going to be 1 minus 5 plus 3 upon 2 minus 3 minus 5, right? So this value is going to be 1 minus, this is 4, right? 4 and minus 1. Minus 1 upon minus 2, right? So this value minus 1 is plus minus, right? So this is going to be minus half. My apologies, plus half. Plus half, okay? How plus half? I'll tell you. So this is 1 get cancelled, right? So 1 minus plus, right? 1 minus 1 by 2, right? So this is going to be 1 by 2, okay? So value of x1 is 1 by 2, okay? But we have to find till second iteration, right? So now we'll find x2. X2 is going to be then x1 the formula, right? This one, xn equal to xn, then this x1, this is x0, right? So x1 minus this one fxx equal to half, right? A half, or we can write 0.5, 0.5. So we'll put the value. So this is going to be this one fx1 upon f dash x1, right? So this value is going to be 0.5 minus, I'll put the value, so 0.5 cube minus 5 into 0.5 plus 1 upon 3 into 0.5 minus 5, okay? Because these are the value of n f dash, and we'll put this at x equal to x1. X1 value is 0.5. We'll put the value, right? And we'll solve it. This is going to be 0.5 plus, okay, this plus minus plus, this value is going to be 0.625 upon 4.25, okay? So x2 value is going to be 0.64705, okay? So this is the answer. So after second iteration, that is x2, the value of x is this, okay? This we need to find out. So this is second iteration, okay? This is the first iteration, right? Very simple question. Well, now next question is which is asked in CSIR net, okay? Question is, this is CSIR net question, very simple question, okay? So find out, okay, so x is given root n, okay? This is the given, and we need to find out Newton-Raphson iteration formula, okay? This one, this is given, and find out Newton-Raphson iteration formula. Okay, x is given, and we have to find out Newton-Raphson iteration formula, and options are given. Xn plus 1 equal to xn by 2 plus n by 2xn. Okay, very simple question. B is given, xn plus 1 is given 2xn minus n xn. Okay, option C is given xn plus 1 equal to xn by 2 minus n by 2xn. Okay, option D is xn plus 1 equal to 2xn plus nxn. Okay, this is the question, guys. So I'm going to solve it. So here we have given very simple question, guys. Okay, 3.5 marks question, given x equal to n. So it means we can write x minus n equal to 0. That implies function is going to be x minus n. Okay, function is going to be x minus n. Well, so this is the function. Now we can easily find out this. So fx is this, then we'll find x n plus 1. This is going to be x n minus f x n upon f dash x n. This formula we know, right? This is simple. And fx is this, means fxn is going to be from here, fxn is going to be xn minus n, and f dash xn is going to be, will differentiate it, this is 1, right? This is xn square, guys, right? Xn square, x square, this is x square, guys, x square. Okay, so this is going to be f dash x is 2xn. Okay, because this is x square 2x, right? And at x equal to n, 2xn, right? So we'll put the value. So xn plus 1 is going to be, xn value is xn minus fxn value is this, xn minus n upon this is 2xn, right? We'll solve it. So this is going to be xn plus 1 is going to be equal to xn minus this one, xn upon 2xn, xn upon 2xn, and this is minus minus plus. Okay, plus n upon 2xn, right? This xn is will get cancelled. Okay, this is xn square, guys, right? xn square, xn square. Okay, so xn square will cancel by 1, so this is xn minus xn by 2 plus n upon 2xn, right? So xn plus 1 value is going to be xn, this is xn by half. Okay, we'll subtract xn by 2 from xn plus n upon 2xn. Okay, so this is the answer. Which option is matching, guys? Option A is matching. Xn by half upon n upon 2xn, right? Very simple question. And CSIR net questions. One more question which is asked in CSIR net. Okay. The question is x is given, x equal to x minus 2 sin x. Okay, CSIR net question, CSIR net question. Okay, okay, x equal to 2 sin xn, right? And you need to find xn plus 1. Okay, I'm not writing options. Options will directly get the answer. Okay, so we know xn plus 1, we need to find out. Okay, so we know the formula, xn plus 1 is equal to fxn, my apology, this is xn minus fxn upon f dash xn, right? This is x, right? So we'll find fxn. This is fx, right? So we'll find fxn is going to be xn minus 2 sine xn, okay? And f dash xn is going to be, we'll differentiate it, 1 minus 2 cos xn, right? We'll put the value, so xn plus 1 is going to be xn minus 2 sine xn upon 1 minus 2 cos xn, okay? Now we'll solve it. So this is going to be, xn plus 1 is going to be, we'll multiply this, so this is going to be xn minus 2 cos xn minus 2 cos xn into xn, right? This is, we have taken LCM, okay? And minus plus 2 sine xn, okay? 2 sine xn. So xn plus 1 is going to be, this is upon 1 minus 2 cos xn, 1 minus 2 cos xn, right? So xn, any mistake we have done? Yes, xn is also in that, right? So this is minus xn plus 2 sine xn, okay? 2 sine xn. So we'll solve it now. Simple. So this is going to be, this will get cancelled, okay? And we'll take 2 common, and this is going to be sine xn minus cos xn into xn, okay? Or we can write xn cos xn, okay, upon 1 minus 2 cos xn, okay? So this is the answer, guys. And minus 2 cos xn, okay? This is the answer. This is the value of xn plus 1, 2 sine xn minus xn cos xn upon 1 minus 2 cos xn, okay? So this is the answer, okay? So this question is also asked in CSIR net. I haven't written the options directly, I have got the answer, okay? So this is the correct option or answer, okay? Well, so guys, I'm going to stop here, and also I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay guys, thank you, bye now, good night.